Welcome to my fifth section, NLP with Keras. In this section, I'm going to give you an introduction to what NLP is. I will show you how to build a sentiment analysis engine using NLP. We will then build a chatbot together using NLP and implement that chatbot. NLP and Keras, an introduction. In this video, I'm going to introduce natural language processing, and I will tell you how to go about building an NLP pipeline. NLP, what is it? Stands for Natural Language Processing, not to be confused with Neuro-Linguistic Programming, which is something else entirely. The best way to understand NLP is that it's a technology to aid computers to understand humans' natural language. But there's a lot of complexities when we think about language that make it hard for computers to really understand it. There are things like multiple languages, things like sarcasm come into play. Things like context as well are very important, and these all add to very difficult challenges for computers to start understanding how humans interact. However, natural language processing is in use today in the real world, and you have probably encountered it in some form or another, and you may not have even been aware of it. This lists out some areas where NLP is in play today. Things like information retrieval, information extraction, for example, obviously translation from one language to another, things like simplification of text or summarization of text. You will have NLP in use around spam filtering, as well as in things like auto-prediction or auto-correction. And then things like question and answering, which are a lot harder. These are becoming more common use cases. So when we think about building a natural language processing pipeline, there are 8 key steps to think about. Sentence segmentation, word tokenization, predicting parts of speech for each token, text lemmatization, identifying stop words, dependency parsing, finding noun phrases, and then named entity recognition. Let's dig into each of these steps. Let's say we have a sentence here describing the planet Mars. The first step is sentence segmentation. This is a paragraph and it's got a couple of sentences, so we segment those out into 2 separate sentences, and this reduces the size of our dataset to allow us to start doing additional things with each of those sentences individually. The second step is to take one of those sentences and tokenize the words within it, and this basically means identifying each of the words within the sentence. In the third step, we're predicting parts of speech for each token, and by this we mean identifying the types of words that they are. So for example, Mars would be identified using a pre-trained model to be a noun. Then once we've done that, we can move to something called text lemmatization, and this is really identifying the root of certain words. So some words, in English for example, are extractions on top of an existing root. Plural words are a good example. In this case, we've identified a couple here where be is the root of is, and for is the root of fourth. If there was a plural word in here, could have made the root being the non-plural version. Then we identify stop words, and these are words that are not that significant in the meaning of the sentence. So here, the ones highlighted in grey have been recognized as stop words. Things like is, the, from, common words that really, if we remove them, the concept of the sentence still maintains its context. Then we do some dependency parsing to try to identify which words are related and where does the root begin. So we can see, kind of identifying here, that the root aligns around the fact that Mars is a planet. Then we want to identify noun phrases. So this would be around phrases that make up something we'd want to consider a noun. So the fourth planet, for example, or the sun, or the solar system could all be identified as noun phrases. These are a grouping of words that come together to form something that we can classify as a noun phrase. And finally, we want to do named entity recognition around geographic entities, people entities, and location entities. In this case, Mars potentially could be identified as Mercury and Sun as geographic entities. And this just helps identification and breaking down of our sentences. So with all of these steps, we then have a set of information that we can then vectorize and pass into a machine learning model to help it understand and learn about what we're trying to achieve.